Hello, so in this video we're going to take a look at some of the basics of interacting with SSH, a very core and important service when doing Linux administration. So one of the first things I'm going to do here is make sure that my networking is set appropriately. We've been messing with the networking in previous videos, and I want to make sure that my two machines that I'm going to be using here can actually see each other. So I've got my MSF admin account, my Metasploitable guy, and my Kali Linux account. Those are the two computers I'm going to be using for this. And I happen to leave off, if I check an IPA, I happen to leave off where my Metasploitable account was behind the CENT guide, the 192.168.2 network. So I'm just briefly going to go ahead and change this. So this really has nothing to do with SSH, but I want to make sure that my two machines can see each other. And if you've been following the videos all along, then this is just your SSH connection isn't going to be there. So sudo nano /etc /network /interfaces, something we've been doing kind of all along. And here's where you can see I left in that gateway 192.168.2, and I'm going to remove that from my interface file, as well as change myself back to the 192.168.1 network, and then I'll go and save these changes and then restart my networking by doing a sudo /etc /init.d /networking restart. Okay, so reset my interface as I do another IPA, and I should hopefully be now on the same network as my Kali Linux machine. So he's on 192.168.1.103, and if I try pinging my 192.168.1.101, that's where my Metasploitable machine is. You can see I do actually have line of sight to him. So just making sure they're on the same network before I try going through and checking these the SSH service. So out of the box, Metasploitable does have SSH. It is running an SSH service, and it does matter which version of SSH are you running. So that is something to kind of become familiar with. What type of SSH server do I actually have running? Might be worth just Googling it and learning a little bit more. Is there anything unique about your specific deployment? I'm going to start by looking at some generic commands, so it shouldn't be anything too specific based on whatever version of SSH you actually are running, but there might be a little line option here or there that could change over time based on whatever it is that you're doing. So let's see the basics. So right now, MSF admin, that Metasploitable machine is running an SSH server. Out of the box, how can I use SSH to connect? So SSH gives me a secure connection to the device that's actually running the server. So that's my MSF admin account. So the way I would do this on the Kali Linux side is if I was an authorized user, at the terminal I would type out SSH. I would then type out the user account I'd like to connect as. So let's say I want to connect as MSF admin and then I would do the address, 192.168.1.101. And when I do this, it's going to say, hey, I've never interacted with this server before. Here's a unique RSA fingerprint for this server. Are you going to trust the server so you can have a secure connection with him? And in other words, we're going to say, yes, I would like to connect to this server. I know I've never seen him before, but this is kind of the first one-time message that you'll get every time you connect to an SSH server that you've never actually connected to before. So we'll say yes, and then it's going to say, okay, we've added him to the list of known hosts. Okay, we'll remember that for later, known hosts. And then it says, okay, well then what's MSF's admin's password? So if I was an authorized user, I could now try connecting using his password. So I type in MSF admin, and you see I now have a secure connection over to the MSF admin account, over to my Metasploitable machine. So if I do something like an ls, you'll see we're now looking at files on the Metasploitable account. So we have that James folder that we created in a few videos ago. Remember, I do my ls here, and I end up seeing the same thing. So we see here effectively SSH gives us a terminal on someone else's computer. If I can log in on SSH, it might as well just be sitting there at their computer with a terminal. So very, very useful. When I want to exit, when I'm all done interacting with the computer using SSH, you would just type the exit command. That closes the connection. You see it logs me out, and now I'm back to just operating as Kali. So that would be a typical authorized user going and using SSH. Now let's start looking at some of the little nuances and other things that are good to know about operating SSH. So we saw there that there was a list of known hosts. Okay, there's a list of known hosts. So let's take a look at what that's all about. So an important thing to realize whenever you're using SSH is that there's a lot of your settings and configurations and history that ends up getting saved to a couple important places on the computer. So let's take a look at some of these. And one of them is in our home directory, okay? And so if you do an ls in your home directory, all you see is your desktop and documents and downloads. We don't actually see what we're looking for. And that's because the folder has been hidden, all right? So if we do an ls space -a, this will show us all the directories that are currently in here as well, everything that's been hidden. And you'll see all of those start with a dot, okay? So we have one that's .ssh. So it's been there all along, but if you don't do the -a option, we don't actually go looking for it, we simply don't see it. So this is something that I could cd to. I could go and look and see what's inside it, and you would just do a cd .ssh. And I'm now in this SSH directory that I didn't even know was there. And if I do an ls in here, what do I see? You see there's now this folder in there called known hosts, or excuse me, this file in there called known hosts. So let's take a look at what this actually looks like. I'm just going to cat it out, cat known hosts. And you see it spits out a bunch of technical jargon, and all this technical jargon indicates is this is the fingerprint, that unique fingerprint that I associated with a particular server. So if I try to SSH to a server that actually has a fingerprint that's the same as someone in my known host file, I'll automatically trust that server. If they are not in my known hosts, then it'll prompt me to say, are you sure you want to connect to this guy or not? So realizing that this particular file exists and I could have a list of connected servers that I've connected to before kind of in this is pretty useful to know as you start troubleshooting or fixing problems or start going to either lock down an account or something along that line. Just it's a good place to look to see start gathering little pieces of a puzzle and gathering useful information. Well, why don't we do that same thing over on the Metasploitable account? So this guy I did not connect to anyone yet. So if I do an ls-a over here, you'll see I do have an SSH that's been hidden as well. So let's go and take a look inside him. Do an ls. You see this time though I have two different files. So I've got this ID RSA and an ID RSA.pub. Okay, so what are these all about? So these are encryption keys, and this is a private key and a public key that allow for encryption to happen through my SSH server. So I don't have a known host because I haven't actually connected to any SSH servers on this side. He's the one who's running the server. All right, and if we take a look at some of these keys, let's just take a quick look at them. So I'll cat out one of these, ID RSA. Oh, permission denied. We'll need a sudo in order to actually do this. Sudo ID RSA. Oops, sudo cat. There we go. And you see it spits out a whole bunch of technical jargon, and it says there end of RSA private key. Okay, so this is the private key that's been associated with this particular account. And in conjunction with the public key is how we're actually managing encryption. Okay, so if I hit a little up arrow again and I do the dot and then this time cat out the public, you'll see it's somewhat similar. Okay, it's a bunch of technical jargon that we end up using that associates this particular server, this particular build, this particular deployment, so clients can actually go and connect to me. So useful stuff to know about. All right, so let's take it a step further and understand what are some more important configurations that are important to realize when using SSH, specifically on the server side. So it's really, really important to keep these keys under control. So the way that cryptology works here is that private key is really meant to be a secret. If anyone were able to get a hold of that private key, they could, it's possible, given particular settings on the server, they might be able to connect to your account without even having a password. So having a unique, hidden, secret private key is really, really important to maintaining good security. The public key would be something, though, that we would go and distribute, typically on a website or whatever. So that one ends up being made known. But the public key is the one that's really, really important, or excuse me, the private key is the one that's really important to keep as a secret. Now, if I was given a machine out of the box, I would not necessarily trust, does anyone know my private key? Does anyone know my public key? I might not necessarily know those things. So what I'm going to do is I'm going to walk through removing the keys as well as generating new keys, just all from scratch. So let's see kind of how that's done. So what I could do here, do an ls. We saw we had these ID RSA and ID RSA pub. I'm going to trash them. I'm going to remove them. So I'm going to do a RM ID RSA, and I'm just going to hit star. That'll remove both of them. Yes, I'm going to hit Y's for those. And then that will allow me, so now when I do an LS, yeah, we remove the write protections on those so that they can be deleted. All right, so both of those files have been cleared up. And that will make it functionally so that no one would be able to connect to my SSH server effectively. So what I'm now going to do is I'm going to generate my own keys. And we can do this through a utility that's built into Linux. And it's called SSH-keygen. Okay, SSH-keygen. So what I'm going to do here is I'm going to do a -T option as I run this and indicate that I would like to do an RSA key. Okay, so that's a very typical one. We saw we just had an ID RSA key, so I'd like to generate another one of those. And now I'm going to do a -C, and then I'd like to put, in quotes here, what the user account associated with this particular key. So I'd like to link this one, let's say, to MSF admin at 192.168.1.101. That's the address where I'm currently operating out of. And close my quotes. So when I hit enter, you'll see it says, hey, we're generating now a new public-private key pair for this with this particular build. Where would you like to save it? And in which location? You see there, by default, it puts it in your home directory, msfadmin.ssh, in that hidden directory, and a new thing called IDRSA. And I'll just hit enter this. This is good. We could have a passphrase in addition to this. In addition to just knowing the key, it might also require a passphrase. I'm going to show what does it look like without the passphrase. So I'll just hit enter to this, hit enter again, no passphrase, and you'll see it generates this unique key fingerprint for my server now. So if I were to do another ls again, you'll see I now have a new unique private key and public key that are now associated with my server. Also, if I do a ls-l to look at the privileges, you see it has automatically changed some of the privileges here on my private key as well as my public key. So that's important to understand as well. Someone could read my public key, that's important, but no one other than the user, MSF admin, the owner of this particular file, could actually read the private key. So keep that in mind. That private key, they're not kidding, is meant to actually be a secret. Okay. So what could we do next? Let's see, wake my Cali guy back up here. Oop. Keep him logged in. Okay, good. So if I were to just kind of do a lot of this stuff again from now that I've generated my own unique keys, remember we had this known host guy over here. Let's say I remove this again. I just do a remove on my known hosts. And then try SSHing to MSF admin at 192.168.1.101. And we'll see, hey, we've got a new different fingerprint this time. Are you sure you'd like to connect? Yes, I'd like to connect to this one. And it ended up adding him permanently with the new keys to my new known host list after I do my MSF admin as my password to actually be authenticated. Okay, so this is me connecting with a new fingerprint and new keys. Again, just kind of something useful to see how to do. Now I'd like to kind of show what would happen, how could I set this up so that I could connect to this computer without even knowing the password, just by knowing the keys or having the keys. Okay, so we can do this by setting up a SSH-copy ID. COPY-ID, okay? I will do a -I and do this through my home directory as to where things are, so /home/msfadmin/.ssh/IDRSA. Okay, I'm going to point to where that particular key is. The account associated with this is msfadmin at 192.168.1.101. Are we sure we want to? Yes. Okay, so I permanently added him to his own list. I now do a, got to type in my password here, MSF admin. Okay, so making sure we haven't added any extra keys, sure. I'm now going to go and check ls/dot/SSH. and we'll see what I ended up doing is I added in a new authorized keys folder to my SSH folder, or an authorized key file, excuse me. Okay, so let's take a look at this new authorized key file. Okay, so I'm going to cat this out, cat authorized. Oop, I'm not in the directory, so cat.ssh/authorized keys. And you see what's now been added to the list is a unique key that's associated with the MSF admin account 192.168.1.101, all here at this account. So if I had something that was built into my authorized key files, what this is telling is, hey, this is a particular user to whom if someone knows the private key, they would be able to connect automatically without knowing the password to the account. All right, so let's say what would happen if I actually had the private key here on my Kali Linux computer. So I'm going to take a look at this, and I'm going to just do a quick copy and paste. So why don't we jump into the file using something like VI. So I'll go VI ID RSA, ID, vi.ssh/ID RSA. Okay, and remember here I'm just going to full screen this guy and say this is the entire key. What happens if I select all of it? Oops, a little too far. Let's go this way. So what happens if I select all of it and then do something like a copy, :Q to quit this file. So I now have the private key copied. And let's say I come over here to a new terminal. And I write that into a file, just into a text file here. So I'm going to, just to keep everything organized, I'll cd to my SSH directory first. And this is where I had that known host. And I'm going to make a new file in here. And I'll make a new one. Let's just say, why don't we just do VI for consistency. And I'll just call it direct, as in like direct connection, direct.txt. I'll go I for insert mode. And I'll hit paste. So I just pasted out this entire key. Okay, so you see here, here's my private key that I've copied over from the other computer. I'm going to hit escape, :WQ to write the file. And when I take a look at this, you see I now have a new direct.txt file. Okay, and this is, I've now copied the private key from my Metasploitable machine over to my Kali Linux machine. Okay, so I'm still connected over here in SSH in this particular terminal. I'll drop my SSH connection. We'll type an exit here. Okay, so now I'm back over here to my Kali account. Root, I'm all logged out of SSH in this particular terminal, and I've copied over this direct public key, or excuse me, the private key into my SSH directory, and here it is in this direct.txt. So let's see one last thing that we have to do with this particular file. Now, if we check the permissions on this file, I'm going to just cd into the directory first, just so I don't have to keep typing out .ssh. But if we check the permissions by doing an ls-l, you see I currently have read permissions for other users, both in the other group as well as external to everyone else on the computer. So one last thing we have to do is actually lock down the permissions on this file. Remember, private keys need to be read-write by the owner only and no one else. So we can do this through a chmod 600. I'm giving myself read-write permissions, not execute permissions, and everyone else has no permissions. And this will be of the direct.txt. Okay, so now when I do an ls-l, you see I'm just removing the read permissions from the other users. And that will allow me now to do a new SSH command, or a different way to connect, by doing a -i. A -i is when we pass in a private key as we try to connect. So I'm going to pass in this private key to the MSF admin account at 192.168.1.101. And this time when you try to connect, you see, I'm in. That's it. I did not have to type in a password or anything. So this would allow an authorized user who had the private key to connect without actually knowing the password. Alternatively, if someone were to steal the private key, you now see that they would be able to connect to your SSH and have full access. Who am I? See, I'm logged in as MSF admin, who happens to be a privileged user on this account, all through just by knowing the private key. So learning how to trash your private key, come up with a new private public key pair is really, really important, as well as paying attention to, as we saw on the MSF admin or on the Metasploitable machine, .ssh, in your .ssh folder, do I have anybody currently listed in my authorized keys? That's something that could also allow a remote connection without somebody knowing the password. Overall, connecting to SSH is pretty straightforward, but paying attention to some of these little hidden files is really important to securely operating an SSH configuration.